Hello, hello. Uh, so let's continue onwards. Um, I would like to implement a bit of the next manager, a resource state manager. It's just gonna be a very, very short wrapper over um, some resource barrier transitions, but eventually it might be extended so that it allows us to track um, resource states. Um, but for now, we will just use a simple wrapper. Yeah, my hope is that we can actually um, implement these different parts so that we can at least clear the swap chain and get a sense of that everything is working as intended. Um, if we add in future, it would be to create a pipeline, meaning shaders, meaning a route description, and after that we have um, resources, buffers, and thereby we can start doing draw calls. So this is kind of a roadmap into um, uh, uh, our plan for this project. I'll put this into a parenthesis since it's not really any near future. Yeah, I might as well save it for future reference. So yeah, we got started on these structures last time. We of course have to implement several methods of each, but yeah, as I've mentioned, I would like to start on the resource manager. Let's create a folder for that because we might want to place the manager in the same folder. So let's say it should be named D12 resource state manager, since it's not an actual resource manager. We will have to implement something that handles resources for us. DirectX12 allows you to handle resources by using different functionality of the API. But yeah, that's a later topic. Just gonna add the namespace. Let's see. Whoops. I'm just messing around with the streaming software. All right. So a resource state manager should also be a singleton pattern. Therefore, we will create a private default constructor. We would like a public static way to get the actual resource manager, and of course we need a instance of it. Let's implement that one, and as per usual, declare the instance in the global space of the CPP file. Never do it in a header file, that will be a world of hurt. All right. I think whenever we do resource transitions, we um, we what was my train of thought? Yeah, whenever we have to change the state of our resources, uh, um, we probably probably need to use the device for that. Most Microsoft documentation on this topic uses a helper in the as you can see here. There's a repo that has several helper functions. As I've said in a previous video, I don't want to use these helper functions, even though it's a bit more code. I think that it gives you a better overview what actually goes into using DirectX12 and why it works the way it does. So, and besides, you would have to install the header files and make sure that your current version of the DirectX12.h is up to date in terms of the helper functions. And yeah, it's just too much of a hassle. It would save you time down the line if you used it, and it's totally fine. There are several different advantages to using it. Texture loading and everything would get way easier, but yeah, we're doing this only using standard libraries for now. So yeah, anyway, we want to transition resources. And thereby we have to use resource barriers, and since the documentation only shows you how to use the aforementioned helper functions, I will look into a previous project where I myself used the explicit the explicit yeah, the explicit version. All right, it turns out it's submitted to the command list. So a resource manager would like a command list associated with it, but yeah. Um, Maybe for now we would just like a wrapper of the function. So if we look up the resource barrier thingy here, um, we can batch uh, the the barriers. Um, we won't be doing that for now. I feel like I'm saying that quite often. the, in terms of DirectX12 possibilities, it's a fairly advanced API, and this is of course beginner friendly, and we have to do everything from scratch, so things have to evolve down the line. Yeah, so a resource barrier is a function call on our graphics command list that passes on a number of resource barriers which handles transitions. So let's look up the resource barriers. They take a type, um, and we can decide whether it's a transition or uh, a transition between uh, types, or we can use it as unordered access views. But mm, yeah, we will probably be using transitions. Um, let's see. Yeah, we will be using transitions. Mm, I'm wondering whether I should just create a static method for now, since it's just a wrapper. And so it will kind of look like the helper functions, I guess. But yeah, we will create a separate section for this. Even though it's static, it might not end up being that if we want to store information. Uh, Even though this is a singleton, so I think that uh, as long as we keep things static, we would be fine. But yeah, let's call it transition resource, and it of course is has no return value. We will, for now, disregard the type. Let's see, do we need any flags? No, we don't need flags. okay, so you can temporarily disable access to different objects. Um, and then we have the substructure of the actual barrier, which consists of a resource and sub-resources, state before and after. Those are really interesting to us in terms of our wrapper function. Yeah, okay, you can see the union here as well. Yeah, so basically we want a function that handles this. The type is always transition, there are no flags, but we want the actual transition barrier we won't be doing aliasing or UAVs. So these two of the three parts of the union can be disregarded. So we basically want this as well. We don't need the, so actually we can delete the whole resource barrier struct because we don't need that. We do need a resource, a sub-resource if needed, or a state before and after. Let's just start with the actual resource. Since we would like to specify a default value of let's just put in a unsigned int of sub resource and a state before and a state after. This should be constant. No, yeah, it was just IntelliSense. I'm pretty sure this is also constant. Since we changed the resource, I'm unsure whether DirectX considers. Yeah, we can probably not pass in constants. Yep, let's create that. So we will be creating a resource transition barrier. No, let's just create a resource barrier and let's call it barrier, since it's really what it is. Let's see, type, it's always a transition in this case. Flags, we don't want any flags, so we will pass in the barrier flags as none. Next we will do the actual transition union. The resource will be our resource pointer, the barrier, oops, shouldn't be using that one, and the sub-resource will be the sub-resource. I think we could specify that as default 0, and we will have a state before, oops, that's actually the wrong order, barrier, state after, and of course we would like to submit this to a command list, since that's what you do. That is what you do. I just thought that we could also do a batch of transitions if we wanted to. Yeah, but we won't be using that for now. So let's see, we want a command list ID, and let's see, graphics command list, resource barrier method. So it's a graphics command list, p command list, and let's see, we of course need to pass that in, and let's do it like this. So we will pass in one barrier and pass in the pointer to our barrier struct. Like that, we can use our resource manager to transition different resources. Yes. All right. So far, so good. Let's see. All right. I think we might be able to maybe test out our swap chain. Let's see. We just need to get some functionality, because our swap chain can create buffers, drop buffers, but we would also like to be able to get the current buffer and actually I think this one needs to go down below, since it's more like a create, do stuff, destruct order that I usually try to do things in. Let's see. So we would like to be able to transition the resources of our swap chain, because that actually has to happen before we can present a back buffer to the screen, we need to transition it. It has to transition from a render target to something that is something that is needed to be presented, and of course the yeah, and of course the 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 same thing will happen for whatever yeah, it needs to happen every frame. That's what I'm trying to say. So we would like some helper functions. We would like to be able to get the current buffer that it is supposed to write to. Maybe we want an inline resource pointer called get current buffer that just returns our buffer arrays. All right. Sometimes we only need the handle to our descriptor for the buffer. So instead of doing this inline, since it's not very complicated, but just a few more lines of code. Yeah, you could do it inline. It probably wouldn't. Yeah, I'm not gonna do it inline, but you could if you wanted. We want a descriptor handle for the CPU to know where to go. And we would like to call it get current render target handle. And we need to implement that. And as before, we will be returning a descriptor handle. It will start at the heap, and it will just do whatever offset for the current buffer we have. When we have two, current buffer will, as you can see during our present method, get wrapped around our buffer count. So when we have two buffers, this can only be 0 or 1, meaning we either have the first descriptor or the second descriptor. If we have triple buffering, of course, we can iterate through all three of those. But yeah. Let's see, did I implement it correctly? So yeah, we would like to return that. Yeah, so we start at the heap, we offset by the increment size, which we dynamically for the specific hardware decided earlier, and we return a handle. now we have actually most components of what is needed to clear the swap chain. And by clearing, I mean whenever a swap chain uh, um, has presented its data, you clear it and you actually apply a clear color. So right now, if everything doesn't compile, let's see, missing default parameter, transition research. It's because I did something that I thought I might not be able to do. Yeah, even though it's kind of awkward, maybe I should just make this more clear by moving that behind. So yeah, first you pass in the states, and lastly you pass in the resource and the sub resource. It's because I would like for it to be 0 and not have to pass in the actual argument, since a random 0 here and there might be confusing. All right, that's how it needs to be done. Default parameter redefinition. Oh yeah, of course you can't reassign the base value. Okay, everything compiles. We would like then to sort of test this out. So we would like to register a command to our command list. Does our command list manager yet have a method for that? I can't remember. Nope. We could do some overloading. Yeah, it would only be for the sake of syntax, and it might get confusing. So let's so the command queue. Yeah, you could get the queue. You could get the fence. Since we only have one command list, command and return command list dot get. Yeah, let's try that. So our command list manager let's see. Huh? All right. Let's see. Did I do something wrong? Should be fine. Should be returning the pointer. Huh? Let's see. This should actually access. Ah, I see. I see. It's because it's actually not a graphics command list. Let's see, a graphics command list. Yeah, so we need to cast it. Let's see, maybe we could cast it as a maybe we could just cast it yeah, maybe we can just cast it. Maybe we want to actually graphics command list pointer, and let's cast it as such. There we go. So yeah, now maybe we actually do want to overload the operator because this gets sort of silly. So let's say we want to let's say we want to cast this as a graphics command list. I don't think we should do that. Let's see, operator, cast it like that. We would like to return, let's see, an access operator. And we of course have to let's see. We would like to perhaps this is stupid. Perhaps this is stupid. Perhaps we would rather have something like let's try this out. Static get command list. And let's return the command list dot get the actual pointer of it, but return it as another type. We cast it as that. We could do an implicit operator. Yeah, but that's that. Yeah. So this should be fine, right? Get command list. And then we can, yeah, that looks better and is more concise. For now it will work, but maybe we have to refactor it eventually. All right. We want to, as promised, clear the render target view. And we need a descriptor handle to our render target view, and then we need an array of colors, RGB colors. Let's just look up the method. Not get command list, clear render target view, D12. Reminds me of the band D12. Let's see. So far we've been going for about an hour. Yeah, so set all the elements in a render target to one value. We pass in the CPU descriptor handle to the structure. So wherever that descriptor lies in CPU memory, we pass that in. We pass in an array of 4 floats, and we pass in the number of rectangles and the rectangle structures. We're not going to do separate rectangles of clearing, so we will just pass in let's see, we will just pass in 0 for those. So let's start with it's red, green, blue, and alpha. So let's clear something. It's not normalized our data format, so I think this should be fine. We of course need to force that they are floats. I think maybe, yeah, okay, maybe it would get stored no matter what, like a float, if we're explicit like that. But anyway, so let's say that we would like to do this for our SwapChain's render target. We would have to tell the SwapChain to give us the current descriptor for the current buffer. We could pass that in as well. Let's see, the first argument was the descriptor, then the clear color, then 0, and null pointer. We could just do null, null. It's all the same, but yeah. All right. But before we do this, we actually need the resource to be in the correct state. Therefore, we need our resource state manager. Resources and state manager. Almost sounds political. Let's see. Let's use our resource state manager to transition a resource. We want it to be. Did we initialize the resource with any default resource when we initialize them? The buffers. No, it gets initialized with some default parameters. Let's see. I think DirectX and the SwapChain sets the buffers as a proper resource state. So I think it gets set into %. Oh, whoops. We need the command list. Then we want to set the state before. Then we want to set the state as a rendered target. And we of course want our current resource. So let's call the method we just created on the swap chain. And yeah, that should actually be it. Now we transition the render target view from percent to RTV. And yeah, I actually think we so far this should compile. Oh, it doesn't. Get current buffer. Whoops. Yep. And everything works fine. Right now we simply add this command. We also add this command, as far as I remember. Yeah, we actually add this command as well. For readability, we could use something like that. But yeah, we're not gonna do it for now. All right. We would still like to be able to execute a set of commands. Right now we just register them. In our command queue manager. Yeah, maybe it's let's just delete that. Debugging. And mind you, we're doing all this in our initialization method. Yeah, so we should get into actually executing the command list. Let me see. So far we have done much of the basic structuring, link command list and command Q to do execution. All right. Mm. Let's see. I'm just gonna look something up. Mm. We want to close the command list. And then we want to execute it. And that is done from our command queue. I'm just thinking. I think this might be a more suitable name, since we actually get a graphic command list. We would also like to be able to, let's see, does it work if we do a static inline command list pointer? Get command list, return m instance dot. Does that work? Yeah, it does. I think so. Yeah, everything works. We could actually do that inline as well, but things might get, yeah, we're gonna do that instead. Let's do that instead, because these are so short functions. All right. Our command queue allows us to get the queue. Maybe we want this to be static as well for now. Let's see. Yeah, I might change this again because we should be consistent at least. Yeah, we called that on the actual instance. Everything compiles. No need to change anything. We could then ask our command queue manager to get our queue, and we could execute the. Actually, I think that I want to create a wrapper since there are actually both. Yeah, we need to increase the fence as well. So let's just say that we want to be able to be able to yeah, void execute command list, and it will take a pointer to a ID3D12 command list. And that should be it. Everything else should be handled internally. Let's see. So let's execute the command list. For now, we will just be passing in a command list. And yeah, I saw that it has to be const, so we will cast it as a const. Let's see. A pointer to a pointer that doesn't get changed. Yeah. And then we want to increase the fence value and tell the GPU that we set this fence as our incremented fence value. And we want to get a signal whenever that chain of commands is done. So now we can call, after we close the command list, we can execute the command list. Let's see. We do have, I think, some sort of problem. Let's see, maybe I made a mistake in. Let's see, let's just step through. Let's see, locals, nothing. Let's see what happens if we comment this out and put a step. Huh? Well, hmm. Oops, we're not in debug mode. There we go. Yeah. This is, of course, yeah, everything works as intended. All right. Whoops. Let's get rid of that one. So yeah. Let's see. Then perhaps we would like to yeah, before we close it, we have to transition the resource back to a present state. So let's just flip these. And then we close the command list. Let's see. And then we would like to actually present the let's see, yeah, and we of course need to is referenced on, yeah, so we need to wait before we actually leave this part of um, leave this scope, because otherwise we destroy our objects while frames are in flight. Let's see, just a moment. Sorry about that. Yeah, so we would like our command queue to, yeah, I'm not sure. Actually, this has to do with the waiting, but we would like to be able to um, ask the fence, how far are you? And for that we need a pointer. So we can ask our command queue manager to get the fence, and we can actually get completed value from that fence. So while this is lower than our command queue manager current fence, which should get increased whenever we submit something. We want to do a thread pause thing. Let's see. We will just use some intrinsics for that. And we could do gx print. What did I call the helper function? Yeah, print n waiting. Let's just try that out. Let's see. We still do get an error. Let's see. We actually didn't do any waiting. We actually didn't do any waiting. let's just step through, see what happens. Yeah, I think it's because the lifetime of our objects get destroyed before we actually send anything to our handle. So now is the time that we restructure our renderer a bit. We would like for it to actually have some components. Right now it doesn't really have anything. Yeah. So what do we want it to store? I'm pretty sure the device is pretty useful for mostly anything. But I'm not sure that we need to keep the factory and so forth. Let's just create a device. We could create a a pointer instead. Do we actually create anything that means that it's mostly for reference counting? Maybe we just store the pointer, but the object might get released. Yeah, I think for proper lifetime management, we would like a way to store an empty device on our renderer and destroy it. We're just gonna move this since we will be calling the init method on that. Let's see. So now we can create a empty device, but we can also initialize it later. Or yeah, let's see. We would like for it to be referenced as long as the renderer runs. Therefore, I think the renderer should own the device, not just store a pointer to the underlying API. So we do the same, but instead we change the renderer. Let's see. So the renderer instead just gets its device initialized. Let's see. Even though the SwapChain references the device by creating different resources and so forth, yeah, I would like the renderer to have ownership of the actual device. Yeah, so that's fine. That's the first part. Then we would like a swap chain. Let's see. I think I need to include the headers instead. So we need the device and the swap chain in our renderer. Yeah, there we go. And we would like a DXGI swap chain. And the same thing goes for our swap chain. We would like an initialization method that takes in the same parameters as this method. And we want to create that and just move this code into our initialization method, and we want to do initialization with these values. Let's see. All right. Let's just pass on the values. All right. Okay, we might have some. Yes, this should of course be initialized as a null pointer. Let's see, error list, warnings. So far, nothing else. So the renderer now. This should still compile, right? Not yet. Yeah, I think we need to apply the export functions. Let's see. This should solve that warning, right? Huh? Did I change something somewhere? Where did I change something? Uh, yeah, we're not going to use these. Let's see, does this compile? Oh, well. Did I forget a semicolon? No. Is this the problem? Huh? Does this help? Let's see. I guess because I included in the renderer header instead of in CPP files, I have to actually um, DXGI. There we go. Yeah. What would happen if I didn't include them here? Would that actually compile? Let's see. Let's see if I still let them be here. No, it would still give me problems. All right, so let's see. The renderer, the swap chain needs to include afterwards our global settings, I think. Yes. All right. We still do get a null pointer, but now we can actually initialize our swap chain instead. We want to call initialize by using the same parameters. Let's see. There we go. And of course we want to get our information from the swap chain. There we go. As you can see now, we clear the screen during initialization to our color. And no error messages or anything. Yeah. Did we even get a weighting? No, we didn't. Our hardware is too fast. So let's say we wanted a blue screen. Oh, red, green, blue, of course, RGB. I'm sorry, a green screen. Yeah. So, whoops. That obviously shows us that whenever we close our renderer, we need to call release on the member variables. So the swap chain needs to release. The device also needs to reset it. Since it's a comp pointer, we can just do that. Let's see. Let's see. If we wait long enough, we won't get. We will get that error. Let's see. If we remove the stuff here. Let's see. Yeah, we still have a few bugs. Let's see. Yeah, for whatever reason. Uh, let's see. Something doesn't get released properly. And then maybe this will work. Nope. Something is still in flight. Let's just test this out. So the error doesn't get proc before that. Yeah, so maybe we shouldn't reset the com pointer since it's probably referenced someplace else, and yeah, maybe that's not a nice feature to have. Let's just release the resources, and whenever this goes out of scope, it should release. Don't I? I think that we might want to. It's referenced in the command allocator, I think. That is the problem. It's not because we released a swap chain. I'm pretty certain. Let's just test that out. So the command list manager. Let's just give that a basic reset function. Let's do that. Reset commands and well, not that then. The allocator. Reset the allocator. Let's see if we need to do anything about the command list. Set do we need to command list close? I don't think we have to open it again, but yeah, maybe this will fix it. I could imagine that it would, since I think the allocator might be referencing the resource. Let's see. No, that's not it. Resource 2. A resource at, let's see, The memory location is 2D20 and the last one is 60. So yeah, I think it's one of the resources in the swap chain. Is it because no, this should. So it's simply in use. I wonder what is referencing it. Object deleted while still in use. And as you can see, our debugging layer of DirectX12 now gives an output. Let's see. Maybe we want to call this whenever our renderer gets destroyed to get a status of what objects are living when we try to close it. So yeah. So there's a lot of objects living. So we actually need to clean up or do we have to? 14 reference counts on the device. Let me just see. What am I doing wrong here? Of course, we can release the swap chain. Let's see. So actually now we do not have any live objects. So let's see. The swap chain. Maybe I actually get an exception before we get to that part. Yeah. Something happens inside that. So let's just check out the release function here. So we step into that. We step into the drop buffers. And now the buffers, array buffers, they should be 0. I think because this just resets the, I think this needs to be release, or rather this has to be release. There we go. Let's see. Did that not help? No, it didn't. And let's stop reference counting it as well. Alright, nothing crashes right now, but maybe this is the correct way. Let's see. Now we get the live objects. We do not have the resources anymore. They are de facto dead. Huh. Let's see. Maybe it's our command queue manager. Let's try out releasing that. Yeah, I'm pretty sure we're getting close. As you can see, it is really nice to have the different debugging functions. Alright, let's just release these things and do the same thing for our command list manager. Let's do a release function here as well. And let's do reset commands and a command list reset as well. Alright. Let's do that before we entirely close the renderer. Release it. Oh, well, git release. Yeah, we could do the syntax in another way. We might end up refactoring so that we don't use the git. Let's see. Let's not do that. Alright, when we don't step into that, we get into trouble. So let's see. Let's see, is it our swap chain that is the problem? Let's see. Let's see, what do we initialize? So our command queue manager will reset. Let's see, we want a let's see, fence. Let's see. Let's see. Uh, just trying to find out what we need to release. Do we need some kind of flush method? If we, before we release this stuff, get queue, and we signal the get fence, or rather, yeah, get fence. and our maybe we want to flush like that. Yeah, okay. So when we're at that synchronization point, we actually still have everything in sort of scope on the GPU. And if we want to flush the GPU, we actually need to kind of clear the scope. Let's see, let's create a method for that. So we would like a function called flush. And we will be interacting with our swap chain. We want to return an unsigned integer, frames in flight, and we will just return our buffer count. We will turn these into inline functions. Did I actually remove a inline function at our device? Can't remember now. No, not there. Did I remove something here? Maybe it was that function that I removed. Anyway. So this will be the amount of frames that needs to be flushed. Let's see. Where is the signaling? Oh well, I'll just write it out again. So for every that needs to be flushed, we will do so before we close the application. So our command queue manager will get the queue, and we will signal a fence for this fence, and we will add in each frame. And lastly, when we actually release our command queue, we will wait for the flushing to be done. Therefore, rather, we would like to flush before we close our application. Yeah, everything works as intended. And as you can see, D3D background thread has closed. All right. Do we still report live objects somewhere? Okay. Let's see, reset. device reset. Now we almost do not have anything left. We have a device and an allocator. Maybe I think this has to be reset at the end. No. We still have a device of sorts. Let's see. Did we? We actually do reset those. Let's see. And we do. Yeah, of course we need to release the allocator as well. Oops. It's not enough that we actually reset the DirectX component. And I think that was it. Yeah, okay. So our problem was that we need to flush the renderer before we actually destroy it. And yeah, it's because the same thing as what happens on the CPU side when something is in scope, and if it's referenced, whenever you try to destroy objects that reference it, you end up trying to access something that might have been destroyed at another time and in another time, rather in another timeline. So yeah. All right. This has taken us 2 hours. I'm just gonna delete that code since we do not need it. When we close the renderer, we would like to get a report of the live objects. As you can see, our debugging layer gets called correctly. Yeah. And as you might have noticed, we start to get certain parts of this function that is actually something that does not belong to a initialization method. It is actually somewhat more of a draw call, or at least the beginning of it. So it's something that we would like to do every frame. Yeah. And our next project is somewhat still in this area, but we would like to implement other parts. of the renderer to be able to render something else than just color. We would like to create an actual GPU pipeline that allows us to use the GPU to do calculations and rendering. And that consists of loading data and setting up a pipeline. So that is a somewhat monumental task. Yeah, as you saw in this episode, we might restructure things as we go along. I'm still indecisive whether I just want everything to be static and callable, or if I would like to use the get. For instance, we could actually just do like this instead. I do find that the static functions, since they reference a static instance, somewhat nicer. At least in terms of readability. But yeah, maybe we'll decide on that whenever we start implementing several more types of queues and so forth. Let's see, so far I've structured it appropriately. So we have all the static methods. We have the specific methods that are actually only called once. Let's see, maybe we should create a private destructor just to make sure that the release function actually does get called manually if we somehow forget to do it ourselves. Let's see if we introduce any bugs. Maybe this will create a, yeah. If we decide that we are not gonna do this manually, it might still work. Let's see. Yeah. This will not know that we actually do have released the stuff. So for now, we will disable the automatic releasing. We will disable while we do manual testing of life cycles. We could or rather, maybe we should just do if we actually do have a pointer. We can reset it. Let's see. And let's see, does this crash then? Yeah, the fences aren't. Release. If we actually do have a fence, let's see. Yeah, we can't wait for something that isn't existing. We're always allowed to reset anyway, because that doesn't really do anything. Yeah, that's way better. So now we just keep these just to track object life cycles. Yeah. Yeah. All right. I really think that is it. If you find any of this helpful, please like, comment, subscribe, or even follow on Twitch. Hopefully I'll be seeing you around.